Class 1, Division 2 hazardous locations are areas where flammable gases, vapors, or liquids are present in the air in quantities sufficient to ignite, but are not likely to be present in concentrations sufficient to produce an ignitable mixture. The National Electrical Code, or NEC, does not specifically define or require Class 1, Division 2 ratings for transformers. However, it does specify requirements for transformers installed at hazardous locations. These requirements include temperature classification, enclosure requirements, and explosion-proof construction. The transformer's allowable winding temperature must be below the ignition temperature of the flammable substances present. The transformer must be enclosed in a NEMA-type enclosure that is suitable for the environment. NEMA 7 enclosures are typically used for Class 1 Division 2 locations. Transformers installed in Class 1 Division 2 locations must be of explosion-proof construction. Encapsulated transformers have their windings embedded in an epoxy resin, which provides excellent protection against moisture, chemicals, and other environmental hazards. While encapsulation does not inherently make a transformer suitable for Class 1 Division 2 locations, it can contribute to meeting the temperature classification requirement. It is ultimately up to the transformer manufacturer to determine if their product is suitable for use in a specific hazardous location. The manufacturer's technical documentation should provide guidance on the appropriate environmental ratings and certifications for their transformers. Refer to the relevant sections of the NEC Articles 500 and 501 for general requirements for hazardous locations. Consult with the transformer manufacturer to determine if the 25 kVA one-phase encapsulated transformer meets the specific requirements for Class 1 Division 2 locations. If the manufacturer does not have a transformer with a Class 1 Division 2 rating, explore alternative solutions such as a liquid-filled transformer or a transformer with a NEMA 7 enclosure. It's important to consider several factors when selecting a transformer for use in a Class 1 Division 2 hazardous location. Firstly, temperature rating is critical. The transformer's maximum operating temperature must be below the auto-ignition temperature of the hazardous material present in the environment. This ensures that the transformer itself does not become an ignition source. Consult safety data sheets and other reliable sources to determine the auto-ignition temperatures of the specific substances present in the location. Secondly, enclosure type is paramount. NEMA 7 enclosures are designed to contain an internal explosion without causing a hazard to the surrounding environment. These enclosures are constructed to withstand significant internal pressures and prevent flames or hot gases from escaping. Alternatively, a NEMA 4 or 4X enclosure might be suitable if it can be demonstrated that the transformer does not pose an ignition risk under normal or abnormal operating conditions. Thirdly, consider the transformer's construction. Encapsulated transformers offer enhanced protection against moisture, dust, and corrosive agents, which can be beneficial in harsh industrial environments. However, encapsulation alone does not guarantee compliance with Class 1 Division 2 requirements. The overall design must meet explosion-proof standards or demonstrate an equivalent level of safety. Fourthly, check the transformer certification. Look for certifications from nationally recognized testing laboratories such as Underwriters Laboratories, or ALL, or Intertek, which indicate that the transformer has been tested and found to comply with relevant safety standards for hazardous locations. These certifications provide assurance that the transformer has been evaluated by an independent third party. Fifthly, consider the transformer's kVA rating. Ensure that the transformer's kVA rating is sufficient to meet the load requirements of the equipment it will be powering. Overloading a transformer can cause it to overheat, increasing the risk of ignition in a hazardous location. Sixthly, review the NEC articles. Articles 500 through 505 of the NEC provide detailed requirements for electrical equipment installed in hazardous locations. Familiarize yourself with these articles to ensure that the transformer installation complies with all applicable codes and regulations. Seventhly, consult with a qualified electrical engineer. A qualified electrical engineer can assess the specific hazards present in the location and recommend a transformer that is suitable for the application. The engineer can also provide guidance on proper installation, wiring, and grounding procedures to ensure electrical safety. Eighthly, check the manufacturer's documentation. The transformer manufacturer should provide detailed information on the transformer's specifications, ratings, and installation requirements. Review this documentation carefully to ensure that the transformer is used in accordance with the manufacturer's recommendations. Ninthly, consider using a liquid-filled transformer. Liquid-filled transformers, such as oil-filled transformers, are often used in hazardous locations because the oil acts as a coolant and helps to prevent the overheating. However, liquid-filled transformers must be installed in accordance with specific requirements to prevent spills or leaks. Tenthly, inspect regularly and maintain the transformer. Regularly inspect the transformer for any signs of damage, such as cracks, leaks, or corrosion. Perform routine maintenance, such as cleaning and tightening connections, to ensure that the transformer operates safely and reliably. Remember that selecting a transformer for a Class 1, Division 2 hazardous location is a critical safety decision. By carefully considering all of the factors discussed above and consulting with qualified professionals, you can ensure that the transformer installation is safe and compliant with all applicable codes and regulations. Additionally, consider the specific properties of the hazardous materials present at the site. Different flammable gases, vapors, and liquids have different ignition temperatures and explosion characteristics. Select a transformer whose temperature rating is well below the lowest auto-ignition temperature of any substance present. Also, consider the group classification of the hazardous materials. Class 1 hazardous locations are further divided into groups A, B, C, and D, based on the specific flammable substances present. Ensure that the transformer is approved for use with the appropriate group. Furthermore, consider the area classification. Class 1, Division 2 locations are areas where hazardous materials are not normally present in ignitable concentrations but may be present occasionally. However, other area classifications, such as Class 1, Division 1, require even more stringent safety measures. Ensure that the transformer is suitable for the specific area classification. Another important consideration is the wiring methods used to connect the transformer. All wiring and conduit must be installed in accordance with the NEC and be suitable for use in hazardous locations. Use explosion-proof fittings and seals to prevent the propagation of flames or explosions through the wiring system. Furthermore, ensure that the transformer is properly grounded. Grounding helps to prevent the buildup of static electricity, which can be a source of ignition in hazardous locations. Follow the NEC requirements for grounding electrical equipment in hazardous locations. Also consider the use of intrinsically safe circuits. Intrinsically safe circuits are designed to limit the amount of energy available to ignite a hazardous atmosphere. If possible, use intrinsically safe circuits for control and instrumentation wiring associated with the transformer. Another factor to consider is the ambient temperature. The transformer's temperature rating is typically based on a specific ambient temperature. If the ambient temperature in the hazardous location is higher than the transformer's rated ambient temperature, the transformer's maximum operating temperature may need to be derated. Furthermore, consider the altitude. The altitude of the hazardous location can affect the transformer's cooling performance. If the altitude is significantly higher than sea level, the transformer's cooling may be reduced, and the transformer's maximum operating temperature may need to be derated. Also consider the presence of corrosive agents. If the hazardous location is subject to corrosive agents, such as salt spray or chemical fumes, select a transformer with corrosion-resistant materials and construction. Furthermore, consider the potential for mechanical damage. If the hazardous location is subject to mechanical damage, such as from forklifts or other equipment, protect the transformer with barriers or guards. Also consider the need for remote monitoring. Remote monitoring systems can be used to monitor the transformer's operating parameters, such as temperature and voltage, and provide early warning of potential problems. Furthermore, consider the use of a surge arrestor. Surge arrestors can protect the transformer from voltage surges caused by lightning or other events. Also consider the potential for arc flash. Arc flash is a dangerous electrical hazard that can occur when there is a fault in the electrical system. Take appropriate measures to protect personnel from arc flash hazards, such as using arc-rated clothing and equipment. Furthermore, consider the need for a maintenance plan. Develop a comprehensive maintenance plan for the transformer that includes regular inspections, testing, and repairs. Also, consider the training of personnel. Ensure that all personnel who work on or around the transformer are properly trained in electrical safety and hazardous location procedures. Furthermore, consider the documentation requirements. Maintain complete and accurate documentation of the transformer specifications, installation, maintenance, and repairs. This documentation can be helpful for troubleshooting problems and demonstrating compliance with safety regulations. Also, consider the disposal of the transformer. When the transformer reaches the end of its service life, dispose of it in accordance with all applicable environmental regulations. Furthermore, remember that safety is always the top priority when working with electrical equipment in hazardous locations. Follow all applicable codes, regulations, and safety procedures to protect yourself and others from harm. Also, if there are any doubts or questions, consult with a qualified electrical engineer or other expert. Furthermore, consider the impact of the transformer on the overall safety of the hazardous location. Ensure that the transformer is installed and operated in a manner that does not create any additional hazards. Also, consider the potential for human error. Design the transformer installation to minimize the potential for human error, such as by using clear and easy-to-understand labeling and instructions. Furthermore, consider the feedback from personnel who work in the hazardous location. Solicit feedback from personnel who work in a hazardous location to identify potential safety concerns and improve the transformer installation. In addition to the above considerations, there are several other factors to keep in mind when selecting and installing a transformer for a Class 1, Division 2 hazardous location. Firstly, it is important to understand the specific requirements of the local authorities having jurisdiction, or AUJ. The AHJ may have additional requirements that must be met in addition to the requirements of the NEC. Secondly, it is important to select a transformer that is specifically designed and approved for use in Class 1, Division 2 hazardous locations. Do not attempt to use a transformer that is not specifically rated for this type of environment. Thirdly, it is important to install the transformer in accordance with the manufacturer's instructions and all applicable codes and regulations. Improper installation can create a serious safety hazard. Fourthly, it is important to regularly inspect and maintain the transformer to ensure that it is in good working order. This includes checking for any signs of damage, such as cracks or leaks, and performing routine maintenance tasks, such as cleaning and tightening connections. Fifthly, it is important to train all personnel who will be working on or around the transformer in the proper safety procedures. This training should include information on the hazards of working in hazardous locations, the proper use of personal protective equipment, and the procedures for responding to emergencies. Sixthly, it is important to have a written safety plan in place that outlines the procedures for working safely in the hazardous location. This plan should be reviewed and updated regularly. Seventhly, it is important to conduct a hazard assessment to identify any potential hazards in the hazardous location. This assessment should be used to develop appropriate safety measures. Eighthly, it is important to use the proper tools and equipment when working on the transformer. This includes using insulated tools and wearing appropriate personal protective equipment. Ninthly, it is important to be aware of the potential for static electricity buildup in hazardous locations. Take steps to prevent static electricity buildup, such as grounding equipment and wearing static dissipative clothing. Tenthly, it is important to be prepared for emergencies. Have a plan in place for responding to fires, explosions, and other emergencies. This plan should include information on evacuation routes, emergency contact numbers, and the location of emergency equipment. Selecting and installing a transformer for a Class 1, Division 2 hazardous location is a complex process that requires careful consideration of all applicable codes, regulations, and safety procedures. By following these guidelines, you can help to ensure the safety of personnel and equipment in the hazardous location. Furthermore, remember to consult with qualified professionals such as electrical engineers and safety experts to ensure that you are making the right decisions.